Chapter 1 and 2 review. Hopefully you watch this, at least go over the review well. Number 1, the WHO are U.S. citizens. You have to read it. Pause the video as you need to. I'm just going to kind of go through the answers, talk through anything that might be confusing. Now, Part A, if you get U.S. citizens, technically it's the 75 U.S. citizens. Well, that leads us to Part C. The population of interest would be all U.S. citizens. Part B, what did they collect? Well, political opinion, which is categorical. Number of presidential elections, which is quantitative in some sort of a count or a number. Number 2, okay. Now, I think on yours it says they could only play one game. I don't know that I have that on here. I thought I did. But they could only play one game. And in that, then we're going to say yes, and a pie chart is appropriate because there's no overlapping categories. I thought I did have that on there, but I'm not reading it on there right now. But that, maybe I explained that only in class, and if you're not in my face-to-face class, then I might be imagining that. But B, what is the least played game? Well, you got to find that, and that's Uno. On a pie chart, you can only pretty much tell what's the least, the most, what are the ones in between. There's not much other information that you can gain from that. That's why we don't spend time doing those. Number 3, an example of a variable that could be categorical or quantitative. I want to go through this one again. This is a terrible answer that I'm going to verbalize here. I don't have it on the page. But I'll have students say, well, cars, and I know I use this one in the video, and then they'll say color of car is categorical. Well, that's true. Now you're talking about color of car, not just different aspects of the car. So color of car, now how is it quantitative? But students will say, well, miles per gallon, and that's quantitative. Okay, those are two different variables. You can't mix the variables because, like, whether we're dealing with cars or people, you can find a lot of variables you can collect, but we're talking about one, so you have to come up with something in general like this, time. Okay, if I don't know, time could be in minutes and be quantitative. Time could be in terms of a long time or a short time, categorical. That's one example. So it's got to be the same thing, time, weight, height. Something can't be a mix of two different things. That'll be on the test. Make sure you understand it. Number 4, survey was taken, and it says identify the who and the what, and if it's quantitative, give the units. So who are Smithfield workers? What? Well, shift, which is categorical. Hours work, which is quantitative, which would be in hours. Full or part-time, which is categorical. All right, number 5, it says, could a pie chart be made from the data? And the first thing in Part A, no, because there would be overlap in categories, or at least likely overlap, that they could play more than one sport or be in more than one extracurricular activity, rather, I should say. All right, so down here I said frequency, I said sport. I should have said extracurricular, sorry about that, rather than sport, but we'll allow that as long as, the general idea is there. Okay, and you should have graphed, and you should have this one be 60 units high, and that's the track, and then label on the bottom. It should look something like this. Now again, this might look skewed to the right, but you could have put track anywhere in here. It could have been in the middle, it could have been on the edge. There's no shape to these. We'll start talking about shape in the next chapter. Okay, so that would be a good graph. C, can you determine what % of boys participated in track or basketball? And the answer is no. Because if you look at this, track and basketball, they could be doing both. But then the next question, D, might confuse you. Can you determine how many boys participated in no extracurricular and football? The answer to that is yes. Because we can say, well, if they didn't participate in anything, okay, that's 15. And then if they didn't, that's mutually exclusive with football. You could do this with did not participate in any of the categories and add them together. And in this case, we get 55 students because there's no overlap in those categories. All the other ones, there's potential for overlap. All right, so now next, number 6, you fill in the table. You have to figure this out. Pause the video if you haven't done it, of course, but across the row you get 30. Across here you take 42 minus 32, get the 10, or you could take 22 minus 12 and get the 10. Add these, you get 50. Total should be 72. Now, that's part A, complete the table. What % of the people like soccer? Well, of the people, we're going to go out of 72. Now remember, on your exam, you have to give context. So I said this P, didn't do this in any of the notes, but that P means probability that they like soccer. So that would be a good way to give context. If you want to start using that P, that's standard for probability of liking soccer. You could say the percent of the people that like soccer. You have to get 1 point for context. Then you have to show the fraction you use to get it. 30 divided by 72. 30 of them like soccer out of the 72, and 0.417. Now, if you didn't turn this to a percent on this test, I'm not going to count it wrong, but it should be 41.7%, and that's the 3 points. Part C, probability they like chocolate, something like that. 22 out of 72, 31%. What percent of the people that like football? Now, liking football, all your numbers have to come out of this row. So the 32, 10, and the 42, those are the only ones you could be using. It says what percent of the people that like football like chocolate. So now in that row, the ones that like chocolate are 10 out of the 42. So we take 10 divided by 42, get 24. Again, context point, fraction, answer. Using statistics, type of ice cream and sport, do they appear to be independent? Sorry, I must not have typed that very well, but hopefully we get the idea. Do type of ice cream, there should be a word do right here, in sport preferred appear to be independent. Okay, so a couple ways we could do this. One is found out probability that they like chocolate given soccer. We already found like chocolate given football, so we have that 24%. So let's do it for soccer, and we take 12 out of 30, and that equals 40%, and that's different than the 24. So see how I said it differs from part D. Another one is you could say those liking vanilla, 18 out of 50 like soccer. So we're comparing this 18 out of 50 to 12 out of 22 in this one, which is 54%. And those are different. There's a lot of ways you can do it. You could look at the row variable with soccer and football, and that's what I would suggest since you already did that in part D. Many times when I ask a question like that, there's something from the previous answer that you can relate it to. So the first one is probably the easiest because you already have some information on that. And if you just compare like soccer and vanilla, or chocolate in this case, then that would be easier. Okay, this one says fill in the table. Hopefully you figured out that this middle number is 9, bottom 28, and 50. Does the class appear to be independent of type of animal preferred? Okay, so I'm going to look at the freshmen and find out what percent of the freshmen like dogs, and that's 12 out of 25. Now, if you look at the sophomores, you have to compare the same thing. 16 out of 25 like dogs, that's 64%. Since these differ, they are dependent, not independent. You'd need to get them very close. If they're pretty close, then you can say because they're very similar, they're independent. So hopefully this is helping. This is pretty much like the test. A lot of this stuff, that worksheet that we had to, it's similar to that. So hopefully you did well. Thanks for watching the video today.